Hi, today we are on the chapter of kinematics. We must know the definition of displacement, velocity and acceleration. And from there we must know the characteristics of how to interpret the displacement time graph and the velocity time graph. Now first of all, what is displacement? Displacement is often denoted by S. Now, displacement and distance, they are two different things. For distance, you will find that distance will never be negative. However, for displacement, it's possible to be positive or negative because displacement measure the position of the particle of the object away from a certain point in the specific direction. So take for example, there's this point here. Now this is 5 meters away. Then if it's at this direction, opposite direction, then this will be minus 5 meters away. Right? So in short, it is like position. And what is velocity? Velocity is the rate of change of displacement. It's how fast an object is moving away or towards a certain point in a specific direction. That is called velocity. All right. So mathematically, all right, it's the rate of change of displacement. So it's ds by dt. Okay, so it is a rate of change of displacement with respect to time. Right. WRT is respect to time. Now what is acceleration? Acceleration is the rate of change of velocity. So mathematically it is dv by dt. Now if v is ds by dt, then you substitute inside is d is the rate of change of the rate of change of displacement. So this is d2s by dt squared. Now acceleration measure how fast the velocity is changing with respect to time. You find that if the object is moving faster, all right, and in a positive direction, then we say that the object is accelerating. Now with that understanding, let's move on to how to interpret graphically, all right, in each of these cases. Now if S is a constant, all right, it's a horizontal line. What does it mean? That means the object is not moving, all right, not moving. Now, if the velocity time graph is a horizontal line, that means the object is moving at a constant velocity. That means acceleration is 0 because there's no rate of change of velocity. Now if it's sloping upwards, then you find that the object all right, is moving at a constant velocity because the gradient, all right, because ds by dt is constant. Okay. Now, does it mean that it is moving away from the origin or towards the origin? That depends on the x-axis. I will not draw it here. Let's say this is above the x-axis. All right, this is the x-axis. That means it is moving away. But however, if the x-axis is on top, then it is moving towards the x-axis because this is decelerating, okay? Because the gradient is negative. Decelerating. Now, what happens if the graph is like that? Okay, I do this first, okay? This one. This one, you realize that the graph is, the gradient is negative, all right? So this is also decelerating. But in this case, decelerating, all right? A is a constant, okay? A is negative. It's a negative constant. This is a positive constant. All right? This is decelerating. Okay, because the gradient is negative. Now, A is not a constant. A is not a constant. This is accelerating and A is not a constant. A is not a constant. Now, look at this. The one below. It is concave upwards. Now, you learn in calculus when the graph is this way, all right, this way, concave upwards. Okay, this is also concave upwards. Now, this one, the one below here, both concave upwards. When it's concave upwards, then d2s by dt squared is positive. That means what? Now d2s by dt squared is acceleration. So this is both means accelerating. Accelerating. Alright, so it's the one below. Now these two on top is concave downwards, all right, concave downwards. So concave, this shape, concave downwards. So that means these are d2s by dt squared is negative. All right, negative means deceleration. All right, this one also means deceleration. Okay, now there's more to it, all right, so please stay tuned. All right, let's analyze further the displacement time graph. Now, what happens if the graph cuts across the time axis, right? The x-axis is actually always the time axis for the displacement time graph. Now, what does this, how to interpret this? Now, you notice that the displacement is dropping, all right? That means the object, but is still in the positive direction. The displacement is still positive. That means the object is getting closer to the reference point. Now, if you take this as positive, this displacement, this direction is positive, so it is actually getting closer, all right, closer to this reference point, but it is still positive. Then later becomes negative, the displacement, because it has overtaken this reference point, all right, and moving in the same direction. Okay, so moving towards reference point. All right, now how about this if the slope is if the slope is cutting the time axis this way? Now the beginning, it is negative, the displacement. That means it is approaching this way, the displacement is negative, all right, because you have measured how far is it from this point, all right, so this displacement is negative, taking reference from here, all right, so this part is negative. Okay, now it's getting closer, and then once you reach this point, it continue to move in the same direction, then this displacement now become positive. Okay, so this is moving towards reference point. All right, this is the point where it overtake. Okay, this is the overtake point. This is where it's overtake the reference point, same as this. Now how about if the displacement time graph is of this shape, V shape or U shape? All right, not necessary to be a straight line. What does it mean? Now you find that displacement is positive at the beginning, so it's getting closer to the object. All right, and then what happened? And then at this point displacement is 0. That means the object has reached this reference point, and then after that it do a U-turn. All right, it gains in velocity, gain in speed, all right, moving away from this reference point. All right, so this is the object do a U-turn. All right, U-turn here. Now let's move on to velocity time graph. Now let's look at the the velocity time graph now. Now you can see that the velocity is dropping. Then you reach this point, the velocity is 0. That means the speed is 0 also. Now when its speed is 0, then later the next moment is the velocity becomes negative. All right, so what does it mean? That means this is a U-turn point. All right, the moving object do a U-turn. All right, U-turn point at this particular time. Okay, now this is likewise. All right, now the velocity changes from negative to positive. All right, negative to positive. That means if let's say velocity is positive this way, positive. All right, the object is traveling this way. Okay, the object is traveling this way. This is your velocity, is in the negative direction and is slowing down. Then, all right, it slow down to a point where your velocity is 0. All right, so your velocity equals to 0. Then after that, it do a U-turn. It begin to travel this way. All right, this will becomes negative. All right, at first it was this become positive. All right, this is negative because it's going this way. All right, negative. All right, so negative, then it reaches a point where the velocity is 0 after a certain time. Then it do a U-turn and the velocity changes from negative to positive. All right, now likewise for this. Okay, this object is here. All right, now your velocity is moving this, the object is moving this way, and we take this as positive. All right, this is positive. Okay, so it's positive, but it's slowing down. Once you reach here, all right, your velocity is 0 at this point. All right, then you do a U-turn. After a certain time, reach here, then you do a U-turn. Okay, now how about this? Okay, you realize that over here the velocity is dropping, so this is a deceleration. All right, so deceleration. All right, then it pick up speed again. all right, it pick up speed again, then it accelerates. Now this is not a U-turn point reference to the movement of the object, all right. This one means the object come to rest, all right, momentarily, all right. So this part velocity is 0. It's slow down, all right. Or maybe I use this. It's slow down, stop, all right. At this point, it stop, then it accelerate again, all right. Its velocity pick up again. That means in linear movement, it's like the object is slowing down, then reach this point, all right, so much so that the velocity is 0, then it pick up again, all right. No change in direction of move. Okay, maybe I write it here. All right, no change in direction of movement. Okay, in the next video, we will use what we have learned a moment ago to analyze 2 displacement time graph and 2 velocity time graph. I will be putting the URL link in the description below. We hope to see you. Have a nice day. Thank you.